In this example, we will graph the trigonometric function y equals to secant of 3x minus pi over 2. Before we do that, we will review the graphs of the basic cosine and secant functions. So here we have the cosine function in red and the secant function in blue. And because these two functions are reciprocals of each other, there is a relation between their graphs. At the x-intercepts of the cosine function, the secant function has vertical asymptotes. Also, the maximum points of the cosine function correspond to the minimum points of the top portion of the secant function, and the minimum points of the cosine function correspond to the maximum points of the bottom portion of the secant function. So, because of this relation between the cosine and the secant function, an easy technique to graph the function y equals to secant of 3x minus pi over 2 is to first graph the cosine function y equals to cosine of 3x minus pi over 2. So then, we will graph the function y equals to cosine of 3x minus pi over 2. This function has the form y equals a cosine of bx minus c. Then in our function, a is 2, b is 3, and c is pi over 2. So we will write that a equals 2, b equals 3, and c equals pi over 2. Before we start the graph, first we need to find the amplitude, the period, and the phase shift. The amplitude is found by taking the absolute value of a, and the absolute value of 2 is 2. The period is found using the formula 2 pi divided by b, and if we replace b with 3, then the period is 2 pi over 3. The phase shift has the formula c over b, then this will equal to pi over 2 divided by 3, which makes pi over 6. The amplitude tells us that the maximum value of the function will be positive 2 and the minimum value will be negative 2. The period tells us that the function will complete one cycle over the period of 2 pi over 3. Then the phase shift tells us that pi over 6 is the x-coordinate where the cycle will begin. Now to the right I will start the rectangular coordinate system, and now here on the x-axis we have pi over 6. To graph this function over one period, we will find the coordinates of 5 points. For this, we need to divide the period by 4 to find a quarter period. So then we will divide 2 pi over 3 by 4, which is the same as 2 pi over 3 multiplied by 1 over 4. Then here we will divide 2 and 4 by 2, and the quarter period will be pi over 6. Next, we will find the x-coordinates of the 5 points. The first x-coordinate will be pi over 6, and this is the point where the cycle will begin. To find the next x-coordinate, we will take pi over 6 and we will add a quarter period. Then x equals pi over 6 plus pi over 6, which makes 2 pi over 6 or pi over 3. To find the next x-coordinate, we will take 2 pi over 6 and add another pi over 6. Then x equals 2 pi over 6 plus pi over 6, which equals 3 pi over 6 or pi over 2. Now to get the next x-coordinate, we will take 3 pi over 6 and add pi over 6. Then x equals 3 pi over 6 plus pi over 6, which makes 4 pi over 6 or 2 pi over 3. And now let's find one more x-coordinate, and for this we will take 4 pi over 6 and add pi over 6, and this will give us 5 pi over 6. Now I will take all these values and I will plot them along the x-axis. So here we have pi over 6, pi over 3, pi over 2, 2 pi over 3, and 5 pi over 6. Now I will write all these x coordinates in a table and then I will use this function to find the y coordinates. So here we have the x coordinates and now we will take the first one and we will replace it in the function to find the y coordinate. Then I will have y equals 2 cosine of 3 times pi over 6 minus pi over 2. 3 pi over 6 is the same as pi over 2 and pi over 2 minus pi over 2 is 0. Then we will have 2 times cosine of 0 and cosine of 0 is 1. Then 2 times 1 equals 2. So 1x is pi over 6, y is 2. Let's plot this point in the rectangular coordinate system. Next, we will find the value of y on x is pi over 3. So y equals 2 cosine of 3 times pi over 3 minus pi over 2. Here 3 and 3 will cancel and pi minus pi over 2 is pi over 2. Then we will write 2 cosine of pi over 2. Cosine of pi over 2 is 0 and 2 times 0 is 0. So 1x is pi over 3, y is 0. And in the coordinate system, this point is on the x-axis. And now if we know the behavior of a sinusoidal function, then if this point was 2 and then the next one 0, then the next one will be negative 2, then 0, then again positive 2. So then I will put these numbers in the table, negative 2, 0, positive 2. And of course we can get these numbers by replacing the values of x in the function. Now I will plot the rest of the points and then I will connect them to get the graph of the cosine function. So here we have the points pi over 2, negative 2, 2 pi over 3, 0, and 5 pi over 6, positive 2. I made this graph dotted because our goal here is to graph the secant function and this cosine function is just a helping graph. Now at the points where the cosine function crosses the x-axis, the secant function will have vertical asymptotes. So next I will draw the vertical asymptotes. Here we have them. And now let's draw the secant function. At the maximum and the minimum points of the cosine function, the value of the secant function is the same as the value of the cosine function. So between these two asymptotes, the secant function will pass through this point and then to the left will go up approaching the left asymptote and to the right will go up approaching the right asymptote. And as you see here, it forms a U shape. Now between these two asymptotes, the secant function will pass through this point and will go down to the left and down to the right. Then between these two asymptotes, the graph will have the same shape as this one. Then this graph will continue to the left and to the right indefinitely. So now here we have the graph of the function y equals to secant of 3x minus pi over 2. I hope you liked this video. Please subscribe to my channel and thank you for watching.